multivariate time series analysis. In this lesson, we will not only create a heat map for each of the technologies to see in which month they generate more energy, but we will also see which ones are more closely related, which have similar behavior among themselves with a correlation matrix. And all, as always, from the data frame where each column represents the generations in the rows on an hourly basis. We will explain the entire process step by step. First, we load the data, as we have done previously. If we use the plot function, it will make a line with all the data. However, it is very diffuse because all the hours are clumped together. We would have to use the resample function for each day, for example, and then we could see something clearer. If you notice with the code, it's very cool because with a simple line automated, many processes that in other tools such as Excel would take a long time, not only in pre-processing but applying with the mouse over and over again. On the other hand, here, just by changing even 7 days, it still works the same way. And even if we want to compare, we can copy and paste the cell. We put 1 day below, put the 7 and see how they compare. Well, month by month. We can also do as we did previously by areas, and it will place one on top of the other. We observe here that in the total generation of each month, we exceed 20 terawatt hours. If we break down the scientific notation, we could even make a bar chart. Although you should already observe that there are times when certain types of graphs do not make sense for the data we are visualizing. For example, among all those we have seen, the one that would make the most sense would be this area chart, which allows us to see the temporal thickness that each technology has according to its generation. But well, let's get to the heart of this lesson, which will be to visualize the correlation of time series, because this time we do not have 2, but we have 11 types of time series. Therefore, to be able to visualize them instead of having 8,000 points of information, as we did previously, we do a resample for every 7 days, for example, and calculate the average generation. We save the resulting data frame with 53 weeks in a year in a variable. And then we use the scatter function to tell it that on the x-axis, I will want one technology, and here lies the problem. Which one do we select when we have 11? For example, I could use coal, we place it on the x-axis, and also on the y-axis we use, for example, wind, execute, and here comes the distribution. Instead of putting coal and wind, I could put here, for example, hydraulic and get another type of correlation. But how could there be all the correlation relationships between each pair of time series? For this, we will use a function from the Plotly library, which is scatter matrix. If you go to this website, you can see all the types of graphs you could make with the Plotly library. For example here, plot scatter graphs, line, 2-dimensional, 3-dimensional, etc., which I would recommend you visit to take a look. But do not get too distracted because there are still many things to see in the course that are more interesting than making all these visualizations. So coming back here, we look inside Plotly, which we have to import before. The scatter function. Here we already see that there is an option that tells us matrix. If we ask in the parameters, it tells us data frame, which is the weekly one we had calculated earlier. Execute. And notice that it will automatically make all the relationships between the different variables we have in the data frame. To see this visualization better, we will increase the height. Let's put, for example, 800 and in the width 800 as well, execute. And here we start to see better how the relationships between the different energy generations are distributed. However, there's a number that would tell me what the best correlation is between any pair of technologies, and that is the correlation matrix. If I go to the data frame, I should think that in this object there will be some function that calculates the correlation for me. Therefore, we look for core. Here we have it, execute. If we look at the parameters, we see that it has been done with the Pearson correlation. Here we see the different ones we can try, although I will not go into detail. If I use this, I can see all the data. However, seeing the correlation numerically does not help much, because we cannot clearly see visually which technologies have the highest correlation. Therefore, we will use the Plotly library to generate this heat map of each of the technologies. We use the imshow function, which at first we have to pass Here it says image, but it could also be a data frame, which has the numerical information of the points we want to represent. Therefore, automatically the function will color those data for us. Let's see it a bit bigger. We give it a height of 800 and a width of the same size. Now we are going to add some text with the correlation with the autotext parameter and tell it I want 2 decimals. To better appreciate the differences between positive correlations and negative correlations, we are going to use a different color scale. In this case, we will go from red to blue. Execute. And considering that the correlation goes from 1 having a direct correlation, that is, the more solar generation, the more wind, or an indirect correlation, -1, the maximum would be the more solar generation, the less wind generation, for example. To better reflect the data, we place it here. We say that the minimum Z will be -1 and the maximum Z will be 1. We can see how the correlation of each technology with itself is perfect, 1. And the pair that has the most correlation is photovoltaic solar with thermal, which is 0.96. If we graph that scatter matrix again with the data frame, giving it that height of 800 and that width also of 800, we appreciate that precisely the photovoltaic solar with the solar thermal is the relationship where the points resemble a line the most. And as they go in an ascending direction, the value of the correlation is very close to 1, 0.96. However, the story will completely change when we look here at other renewables or the pumping, which will be a good correlation. As we see here, because the points are very close together, but it goes in a descending direction. That is, if there is more generation of other renewables, there will be less generation of pumping. I know that during the course I am very practical in performing the analysis and do not go much into detail, but it is still not necessary. If you have any specific doubts, let me know in the comments and I will clear up the doubt to give you guidance. And so, everyone follows the course with the same guidelines, because sometimes if you get too much into the detail, for example, with the theory, you will not be able to see the general perspective of the topic. So take it easy. Practice a lot, not only with the data I leave you in the exercises, but also with other data you have available, or ask me how I could give you references on data tables to work on your own. In this tutorial, I hope it has become clear how you can see in a single graph at a glance all the correlation of the different columns in your data table to see which ones are best related to each other and automatically build your report. And to finish, other types of graphs that we could make with the Plotly library line graphs, as we saw previously, area graphs, which are quite illustrative, or bar graphs. In the next chapter, we will deal with pivot tables, where this time we will see what has been the comparison of the total generation each month for each of the technologies.